Okay, welcome back, class. And today we're going to continue with chapter 12. And today we're going to solve problems using the normal distribution. Okay, so this is going to be 12.5, section 5 of chapter 12. Okay, so here's objectives. We're going to solve applied problems involving normal distributions. Okay, so now, according to the health department, the Department of Health and Education, cholesterol levels are normally distributed for men between ages 18 to 24 with an average or mean of 178.1 points and the standard deviation of 40.7 points. What percentage of men in this age range have a cholesterol level less than 239.15 points? Okay, so the first thing we're going to do is we're going to change this into a z-score. Okay, because we need a z-score in order to use the table. Okay, unless it becomes um, a whole number z-score, but then we can use the empirical rule. But most cases, it's not going to be a whole number. We'd love that, but it's not going to be that simple. So that means we're going to have to use the table, and so I'm going to show you how. So change this to a z-score. So how do we change to a z-score? We use the formula. Observe the value minus the mean divided by the standard deviation. So we plug in the values and we find out that the z-score is 1.5. Now with the z-score, you always go out to 2 decimal places if necessary. So in this case here, it just becomes exactly 1.5, so it'd be 1.50. Okay, and so now what do we do with this? We're going to use a percentile table or a z-score table. And so what happens is this table will give us the percentile for every single z-score. Okay, so this z-score is 1.5. So now if you go to the percentile table and you look for the z-score of 1.5, it's going to tell you a percentile of 93.32%. So that means 93.23% of individuals 18 to 24 have cholesterol levels that are less than 239.15. Okay, so here's how you solve these types of problems. You take the value that they're interested in. Okay, you change it to a z-score. Then you're going to use the table 12.16 in the book. And on a test, I will give you this table as well. So you'll have this table on the test or quiz. But for homework and such, you'll use this table to find the percentile. Now remember, the table only gives you percentile, which is the percentage of values that are less than. Okay? And these percentiles correspond to the z-score you found in step 1. Then what you're going to do is you're going to subtract if you're looking for the greater than. So because they can ask you what's the percentage of values that are greater than some value. Okay, in that case, you're going to have to subtract the percentile from 100. Okay, so you're going to subtract the lesser percentile from the greater percentile if you're looking for between two values, which is what they were talking about here. Okay, so if you're looking for values that are less than a particular value, if you're looking for a percentage of values or the percentile of values less than, then you take the percentage that the table gives you. If you're looking for values that are greater than a particular value, then whatever the percentile is that on the table, you subtract that from 100. And that'll give you the percentage that is greater than. If you're looking for between two values, then you find the z-scores for both values, and then you subtract the percentile for both of those. You subtract the larger percentile from the smaller percentile. Okay. So now in this example, the amount of time that self-employed Americans work each week is normally distributed with a mean of 44.6 hours and a standard deviation of 14.4 hours. It says what percentage of self-employed individuals in the United States work between 37.4 hours and 80.6 hours. So the first step is we're going to take both of these values, 80.6 and 37.4, and we're going to convert them to a z-score. So the z-score for the 37.4 gives us negative 0.5. Okay, and how do we do that? We use observed value minus the mean divided by the standard deviation. So 37.4 minus the mean divided by the standard deviation, which gives us negative 0.5. And then for the 80.6, we do the exact same thing, except we're going to do 80.6 here. And so we get 2.5. And so now what we're going to do, now we don't subtract these two values. That would be a no-no. What we do is we're going to use these two values to look up the percentiles for each. And so when we look up the percentile for the negative 0.5, we find that the percentage of values less than that is 30.85%. Okay, so 30.85% of self-employed Americans work fewer than 37.4 hours per week. Now, what about 2.5? Now, if we look at 2.5, we get 99.38. Okay, so that means 99.38% of self-employed Americans work fewer than 80.6 hours per week. So if we want to know what percentage of employees work between 37.4 hours per week and 80.6 hours per week, what percentage of Americans of self-employed Americans work between those 2 hours? Well, then we're going to take this percentage and then subtract off this percentage. And so if we do that, we get 68.53. Okay. Now, that is the percentage of people, self-employed Americans, who work between those 2 hours, 37.4 and 80.6 hours per week. Okay, so now here's the way you approach these. So here's the summary. Here's the description of the percentage. You're looking for the percentage of data items less than a given data item in the less than a given data item. So with z equal to b. Okay. So let's say you calculate the z-score. And so what's happening? You're looking at the area to the left. And so that's what the table gives you, is the area to the left. That's what you want. So use the table percentile for z equal to b, and then just add the percent sign. Okay. Now, what if you're asked for the percentage of data items greater than a given data item with a z-score equal to a? Well, now you're looking for the area to the right. Now, remember, the percentile table only gives you area to the left. So you're going to have to take whatever the table gives you and subtract off 100, and then add the percent sign. Okay. And then finally, with between two values, you're going to have to find the z-score for both of those values. Then use the z-table. So here's the area. You're looking for the shaded area between these two values. And so you're going to have to look up the percentage, the percentile for both of those values, those z-scores. And then you're going to subtract those two values, the larger minus the smaller, and then just add the percent sign. And so that is the end of this section. It's that easy. So again, practice, practice, practice doing these problems. It's the only way you're going to get good at it. So make sure you prepare for class. And again, don't just take this video and then wait for class. Practice now. See if you get stuck on anything. That's going to help you determine what you need to do in class, what do you need to practice with, what questions you might have, or what you need help with. Okay? So again, practice these, do the suggested homework, do examples out of the textbook, do exercises out of the book. Obviously work on the online homework and such. But again, if you have any questions, reach out to me, bring those questions to class, and we'll work on these in class. Other than that, have a great day. Talk to you later.